Hello everyone. In this video, I would like to go over the operations of J. J is the imaginary part of a complex number in rectangular form. So in order for us to simplify J to the exponent 48, we need to base that on the definition that J squared is equal to -1. So I will use exponential rule to break this into two parts. So what I will do is I will write J squared, all of it raised to the exponent of 24. So as we know that A raised to exponent m, all of it to the exponent n. So I'm talking about the power rules here. So then I will multiply these two exponent. Okay, so if I raise a power to an exponent, then I must multiply by the two exponents. So 2 times 24 will give me 48. So I will replace J squared by -1. So then I will have -1, all of it raised to the exponent 24. So as we know that a negative number raised to an even exponent, I will have a positive result. So in this case, I will have +1 as the answer. Alright, so let's move on to the next one. The next one I have J to the exponent 201. So what you notice that in the first example, I have this as J to the exponent 48. So I have an even exponent. But for number 2, I have an odd exponent. So if I base on the definition of J squared equal to -1, then what I'm going to do is I'm going to break this into J to the exponent 1. Okay, I multiply that with J to the exponent of 200. So I'm using the formula AM multiplies AN. I will have to add the two exponents. So this is the power rule. Okay, so you are multiplying the two powers with the same base. Then what you do is you keep the same base, but you add the two exponents. So what I did was I broke this into two parts, two powers. This J to the exponent 1 and J to the exponent 200. 1 plus 200 would be 201. So the purpose is I want to create this into an even exponent so that I can break that into J squared in the bracket with another exponent outside the bracket, so I can simplify J. So J raised to exponent 1 is just J. And this one, I will break that into J squared raised to the exponent 100. So again, I repeat that formulas. If I raise power to an exponent, then I have to multiply the two power. So you see that 2 times 100 is 200. So I will replace this J squared by -1. So if I raise -1 to the power of 100, so 100 is an even power, so I have negative raised to an even exponent, it will turn into a positive. So I will have J times +1 in this case, so my answer is J. So this is called the operation of J. So whenever you raise J to certain power, you can simplify it to either 1, J, minus J, or -1. Alright, so let's move on to this question here. So this question involving a little bit of algebra, and then we have to remember and distinguish the difference between multiply the two powers and adding the two powers. Okay, so there isn't any formulas for us to add the two powers with the same base. Only the formulas that allow us to multiply the two powers with the same base, then we are adding the two exponents. Okay, there isn't any formulas that has two powers with the same base, and we add it to give it certain result. So for this question, we need to break it into a few parts. So what I'm going to do is I will work with this j to the exponent 301 first. So I apply the concept that I present to everyone above, that I will break this into j times j to the exponent of 300. All right, okay. And I will break this into, so I still add this with j times j to the exponent of 68. Okay, so this is j to the exponent 1 here. So this is j to the exponent 1. And I don't want to write that 1. Like 1 can be invisible. We don't have to write 1 as the exponent. But 1 plus 300 will give me 301 based on these formulas. So this is 1 plus 68 will give me 69. Again, I base it on this number. So now I'm going to apply another formula for this. So I raise a power to an exponent. I multiply the two exponents. So in this case, I am multiply m and n. Multiply by n. Alright. Okay. So now I will work with this. So here's j. I time that with j squared, but here I raise to the exponent of 150. And here I have j, but I time j squared, and I raise this to the exponent of 34. Okay, 34 times 2 will give me 68. 2 times 150 will give me 150. Alright, so this I will have j times minus 1 raised to the 150. And I have j times negative 1 raised to the positive 34. So in this case, I should have j times 1. Okay, so positive 1. Just want to make sure that I write everything down for everyone here. And then in the end, what I have is j times 1 is j times 1 is also j. So in this case, I will have 2j as the final result. All right. Thank you, everyone.